ये नहीं आना। अच्छा, अब आ गया।
मेरे को शक्ल दियो।
अच्छा क्या?
तुम्हारा पिंग है बिल्कुल।
इस पे तो लिंक दूसरा, सॉरी लिंक दूसरा। नया लिंक है, इस पे कर। ये लो लिंक ओपन कर। इसका लिंक शेयर
ब्रॉडकास्ट कर रहे हो?
हाँ,
ब्रॉडकास्ट कर रहे हो, देखिए। ब्रॉडकास्ट कर रहे हो? हाँ। मेरे को अलग लैग हो गया।
साउंड इशू। आप तो बोल ठीक है। अच्छा यूज एक बार ट्राई करियो।
जूम यूज करा?
जूम सबके लोग नहीं कर सकते।
फटाफट वो 2 मिनट की इंस्टॉल से
जूम पे ऑन कर दे, मतलब सामने वाला के सो इंस्टॉल कर देते हैं ना, और जूम पे स्क्रीन कास्ट करके कैसे लोग कनेक्शन कर सके छी?
अनलिमिटेड છે
लिमिटेड છે।
કયો જે આ ગ્લિચ છે જૂમ ફટાફટ ઇન્સ્ટોલ કરી લો 2 મિનિટ की इंस्टॉलर છે। एक्चुअली पहले टेस्ट करो।
टेस्ट कॉल नहीं चाहिए, ओकरा बाद स्क्रीन शेयरिंग बकवास बोले हैं।
स्क्रीन शेयरिंग बोले फटाफट काज करो भाई। अगर एक में दिक्कत है तो फटाफट वो यूज करिए।
हाँ एक लैपटॉप चेक करो तो
लिंक भेजूंगा।
डिस्ट्रिक्ट क्या है? Hello everyone. Still delay due to some technical glitch. So first timer, I am. So, anyways, so first of all, let me just wish you all a happy Diwali, and let's begin with our session. So, in this webinar, what we this will primarily talk about why we have to learn data science. What's the importance of data science, and what are the what are the skills that you need to be a data scientist, and we'll see things in detail. So let me just talk about who am I, and so my name is Vishwanath Jha, and I'm a technology consultant working with I've worked with different clients in personal capacity. I've worked as a data scientist, as an analyst, as a decision scientist, as a software engineer. So a wide array of roles that I've taken over time, and now as an analytics trainer, I train analytics professionals on tools and technologies like R, Python, SAS, Excel, VBA, Hadoop, MapReduce, Spark, Hive, Pig, SQL, statistics, Tableau, machine learning, and etc. So these are few things that I train people upon. Apart from that, I'm when I'm not training analytics professionals, I'm busy building a couple of products dedicated to data science industry in especially in edtech and human resource space. So if you have any queries, feel free to reach out to me on my email, my LinkedIn, my phone, and website. Okay. So now let's begin. What's the outline for the course or this talk? So in this webinar or in this series, first part of the series, we'll talk about data per se. What's data, and why it is important. Why data has become important in the 21st century. Then we'll talk about how the growth story of data, how data grew, and then what problems came up with the growth story of data. And then we'll talk about why there came a rise or the need for data scientists. Then we'll talk about what are the opportunities. And then we'll talk about what are the skills or the superpowers of data scientists. And then at last we'll have a talk about this course, how this course will go forward, and what are the contents of this course. Let's begin. So what is data? So data are raw facts and figures that on their own have no meaning. So the data is actually used to describe any entity. It can be images, it can be speech, it can be text, it can be numbers, it can be symbols, it can be anything. So it can be any alphanumeric characters. It can, every attribute that can describe a particular entity or a particular event that's data. Okay. So now, why data is important? So let me tell you a story about this pyramid. So as you can see, it talks about data, information, knowledge, and wisdom. So data is a raw form. When data is given some context, it becomes information. Okay. Data on its own, it knows nothing. It is pure. It is plain. But when we have information, it is useful because it is organized, it is structured. And using information, when we get the meaning, it becomes knowledge. And knowledge, when we use it as an insight, it becomes wisdom. So everything, if you say this paradigm, data, information, knowledge, and wisdom, that helps us understand how data to insight journey take place. Okay. In the left side, you will see here. This is a very simple diagram. So what I'm trying to describe here is that data helps you take informed decision. Why? Earlier also we used to take decisions, right? The humankind has taken decisions and that's how it evolved, right? But this information, this decision making thing was primarily based on intuition, experience, or on knowledge, that which may go wrong, which may go right. There was no quantitative metric which can define, which can describe the success ratio on that. However, if we have data, data supports our decision making, and which is more accurate than our experience, intuition, and knowledge combined together. Because data, if mined properly, if mined, in a actual, in a right framework, it leads to a insights which will make you take better decisions. So now we'll talk about the sources of data, how the data is generated and where all it is generated. So as you can see, the data comes from everywhere. So it's like public web, social media, the sensor data, the machine log data, archives, docs, media, data storage. It comes from everywhere. And 90% of the data that we have is now unstructured. Okay, so when we say archives, it's like, what are the let's say some books, some documents, government documents, federal reports, medical record, customer correspondence, paper archives, print stream files, everything that documents text that we used to have. These are now, in terms of docs, when we talk about docs, it's like Excel sheets, PDF files, CSVs, format files, emails, Word docs, PPTs. These are all source of data. When we talk about media, when we talk about media, it is images, video, audio, flash, live streams, podcasts, etc. So now, even for the public web, tweets, Instagram, Facebook posts, blogs, census, public finance, everything, the government data, weather report, temperature report, traffic data, traffic details, how people surf on internet, your Google queries, your search queries, everything, it generates data. So you see on LinkedIn, SlideShare, Instagram, Flickr, Pinterest, RSS feeds, they all generate data. So this huge amount of data that we generate, it needs storage, and not just storage, it needs efficient processing, so that if we want to find something out of this data, it should be quick enough to let us know. It should not be like that, if we fire a query to find some relevant data and it takes us forever. It shouldn't happen like that. So this gave rise to a new form of databases, the complete how data is processed, that engine, that complete framework. Okay, so how data grew. Okay, the growth story of data. As you can see, now, as of now, every single day we create 2.5 quintillion bytes of data. Okay, so that's like 10 million Blu-ray discs. If stacked together, it would be like equivalent to the height of 4 Eiffel Towers on top of one another. Okay, not just that, the global internet population grew 18.5% from 2013 to 2015, and now represents 3.2 billion people. That's like combined India and China, the population of India and China. So as you can see, that it's coming from everywhere. The data of size is growing, and it's growing exponentially. Okay, on the left side, if you will see, it's like in every minute of the day there are like it's like 4.1 million Facebook users they give posts. 347,000 tweets are sent every minute. More than 300 hours of videos are uploaded every minute on YouTube. On Instagram, there is like 1.7 million photos are uploaded in every minute. So on Snapchat, 284,000 snapshot is exchanged across users. So it's like on Tinder, on Vine, on Amazon, on Reddit, on Netflix, on Apple. So it's like, as you can see, the social media is buzz, and it is giving rise to it's giving rise to the this, it's fueling this the data growth. Okay, so now that we know what is data, why it is important, and how it has grown over the years, let's check about the few facts about the data explosion. So 90% of the data that is generated is unstructured. It includes tweets, photos, customer purchase histories, even customer service call logs. Okay. Then as I talked about, the global internet population, it grew 14.3% between 2011 and 2013. 3.2 billion, the number of people who have access to the internet today equals that of world's population in 1960. That's like huge, right? Even the data generation by 2018 will be 50,000 gigabytes per second. Isn't that huge, right? So now the amount of data generated since the dawn of mankind has doubled in years from 2011 to 2013. And moreover, it is expected to grow exponentially. So since the beginning of mankind till 2011, the amount of data that was generated, the double of that amount, or exactly the same amount of data, was generated in 2011 to 2013, just 2 years. So now we'll talk about the challenges. What are the challenges that we come across as a data scientist, or with this growth of data? What are the challenges that we face? So the first problem here is the multiple data sources. The data is spread everywhere. It's like universe, and everyone has its own. If you're working on a social media thing, you'll have to combine sources from different APIs of different webs, different government data websites. So it's like everywhere. And the more important part out of this data, like data universe, finding the relevant data is even more important, and that is more difficult. Okay. Now that we have like huge data, and as you can see how the data has grown over like last couple of years, so the conventional data processing engines, data processing frameworks, that is actually that is not up to the mark, or that is not efficient enough to store and process this data. So data crunching on a scale is a very, very big challenge these days. And if you understand that less than 0.5% of all the data we create is ever analyzed and used as of now, that's like like negligible. If you so out of this data, this huge data, we analyze only less than 0.5%. So if you can imagine, you can just imagine what's the the scope of improvement for this data science stream. Now the third challenge that we have is communicating the insights that we generate from these data to third person. It may be client, it may be your team, it may be your bosses, it may be anything. Any person of interest who's interested in your data analysis. You have to generate insights in a more presentable manner. And gone are the days of PPTs and where you just share some documents and things that happen. No, now people want control. They want to interact with your how insight is generated. So that interactive dashboards are the thing right now. So it's very important for a data scientist or anyone who aspires to be a data scientist to be good in storytelling. That's the first important part. Because if you're good at storytelling, you'd be able to find a relevant or a more accurate story about your analysis. It'll give the complete holistic picture of how things are, and what you did, and what things are right now, what you will change, and how the thing it will impact your analysis. So user want that control. Also, the important part here is important challenge here is to the algorithms, the state of the art algorithms, the cutting edge technologies, the algorithm that we have to use now, that we are using now, because the conventional algorithms that we used to have earlier, they were kind of obsolete. They were not able. They were, it would be not right to say that they were not able to mine the data, because primarily whatever the algorithms that we are using right now are based on the previous one. But it would be it won't be exaggeration to say that those algorithms or the from the past, they were actually less efficient. So also the computing power that has grown immensely in last decade, that helped us enormously. So the combined power of computational capabilities along with the new age algorithms, that these things are the challenges. These new things that we have to develop, that was a challenge. Okay, so this gave rise to data scientists. So let us see what the world has to say about data scientists. Fortune's magazine in 2016, they said that nerdy cool job that companies are scrambling to fill. That's data scientist. Forbes in 2012 said data scientist, the definition of sexy. Harvard Business Review in 2012 said the sexiest job of 21st century. Glassdoor in 2016, it said the best job of the year to 2016. And Forbes again in 2016, it said why data scientist is the best job to pursue in 2016. So you see that there is a lot of buzz about data scientists. The whole world is going all gaga over it, because they see the impact. We saw that the huge amount of data that we are generating every moment, right? And then once we are we have the data, everyone wants to know the health of the system, or health of their business, or these things. So in order to generate to analyze the health, even if you go to health record, if you go to a doctor, it analyzes your symptoms and it gives you test. It does some analysis and gives us insights, and based on that it prescribes you. The same thing happens here in data science. So maybe it won't be it is quite an analogy that a data scientist is more like a doctor. He's a doctor of data. Okay. So now, what are the superpowers of data scientists? So yeah, it's like statistics, machine learning, optimizations. That's all. That's one of the major part of a skill set of a data scientist. Programming fundamentals. Yeah, that is important. Then visualization, as we talked about, the interactive dashboards that we to communicate the insights to the third person, the clients. Then it's important to have a business and a domain knowledge in which you are working. So let's say somebody is working in banking and finance. So it's very important to understand how the business works in banking and finance industry. So according to that, you'll find the key metrics and you'll define, things like this happen. Then it is also important aspect, which is big data and cloud computing. As we'll talk about it little bit in the, later. And then again, this communication and storytelling. So let me just talk about how these are important. So programming earlier in the days when we didn't have that much of computational capabilities, and we didn't have that much of data. The job, it was more like a job of statisticians. So data scientists are more like statisticians of 21st century. So in 20th century, statisticians used to crunch numbers, and they used to do some analysis, and they used to generate insights, and used to help governments, businesses, everyday person. Normal, in everyday human lives, we use some. If you buy something, we do some analysis, and then accordingly, it is so inherent that we don't bat an eye for it. That's how it is. But we do use statistics in any kind of decision that we make. Okay, so now what happened? Since the data is huge and it is practically impossible to crunch all that data in manually. So the new programming languages, the statistical softwares like R, Julia, Python, SAS, these languages came up. And when these languages came up, combined with the computational capabilities, it became easier for statisticians to experiment about new algorithms, to see how results change by varying the parameters, like that. Okay. So now the big data thing, because it is with the rise of data, it is important to have a new complete the data storage system. So something like a Hadoop, or something like Spark, where the data is distributed, the parallel, and then it is processed parallelly. So map reduced thing. So that became very important for a data scientist to have. Also the cloud computing thing, like initially we used to have like servers, we have physical servers that we used to create in order to store data and then process them. Now in something with the advent of something like AWS or Amazon Web Services or Rackspace, it has become IBM soft layers. So these things have become less the use of physical servers has come down significantly, and it is more so like more so likely, because nobody wants to if I'm more inclined toward finding and insights or analyzing the data, I don't need to bother about how the data, where the data should be stored, and then practical maintenance of that servers of data. So it's better if it is somewhere outside on web, and on web we just have to upload our data and do some analysis, generate some insights, and communicate it, right? So okay, so let's now talk about what a data scientist is. So this data scientist is a data analyst who lives in San Francisco. So pretty much that's a joke. But jokes apart, if you there are a lot of companies in Valley wherein if you are trying to if you primarily they generally their work revolves around data analysis, and they call themselves data scientists but not more often than not, but the actual things do happen. So what is the basic tools that are very important there? Statistics is, again, as I said, it is important, and data visualization and communication. So as a data analyst, if you'll see, primarily you should know the tools like R, SAS, Python, Julia, to analyze the data and do some little bit of modeling and all the stuff. And then you should be able to what you call that visualize, or make some appealing visualization to communicate whatever findings or insights that you generated and you find that is interesting. So that is important for our data analyst to have, especially thinking like a data scientist. It's like asking the right questions. You have data, you have problem. It's like finding the right questions. If you find the right questions, then you can find the right answers, and finding the right questions will lead you to in the direction of data analysis. If you find right questions, you take one question, try to find the answer for that, do some analysis. Okay, you get some insight. So now you move on to next question. So that's a structured approach. Structured, yet it is out of the box. You don't. It can't be every problem has a different solution. So you have to think differently for every problem, but the core essence, the thought process for data analysis, that remains same. Okay, so now it's like when we come to the companies which are like not non software companies or non data companies per se, actually things become a little different. So there in companies where the data is not that much of importance, they're actually either they are adopting in the adopting phase, or they have just begun. So in organizations like those, it is important to have all these skills, like be it basic tools or statistics or software engineering, machine learning, data merging, data visualization, and things like that, data scientist. So you need everything. You have to be good at everything, because there is nobody else who's gonna help data scientists, because they are just beginners or a very small team. So it is, that's why it is actually, if you'll see, that is why it is very rare to find a data scientist, because it requires skills from all the domains. Like you need business knowledge, you need stats and machine learning optimization knowledge, you need linear algebra knowledge, you need programming and computer science fundamentals. So you need visualization tools knowledge. You know how to tell a story. So it's very rare to find all these qualities in a single person. However, having said that, but these skills can be acquired over the years, over the time, not over the years. You can gain mastery over the years, but yeah, to begin, or to get from novice to intermediate level knowledge, you can definitely acquire it in some time, maybe given a year. You can definitely learn that. Okay. Oh, all right. So moving on to next slide. So what are the most sought after skills in data scientists? So if you'll see, this chart was taken from Cloudflare. They are what they have generated. So if you'll see in 2016, the SQL, Hadoop, Python, Java, R, Hive. You see that the conventional Oracle SQL services, SPSS, SAS. These are coming down. The conventional systems, data analysis systems or data storage system, their use has come down. And on the contrary, the new age tools and technologies, frameworks, they are coming up, and they are actually coming up like huge, exponentially over the years, right? In last 4 5 years, they have seen an immense jump in the adoption rate of these skills, or these skills across companies and across globe actually. Okay. So now, if you'll see, you can see the trends on Indeed.com. They have generated a chart describing how the need for data scientists that has risen over the years. If you can see from January 2006 to January 2015 plus, more like 16. So it is exponential rise, right? Not just that, the amount of jobs or open jobs that has come for data scientists is growing exponentially. The salary aspect, or the compensation or monetary benefits, whatever you call it, that that is also huge in the data science space. Not just for data scientists, but in the complete data science space, from data analyst to data scientist, everywhere. The median salary is, for data scientists, it's $118,000. Okay, that's the median salaries. So if it's like one of the highest paid jobs across globe. Okay, so you can see why you should learn data science, and why you should make career in data science. If gaining knowledge is or staying ahead on the technology is one aspect, but monetary benefits is also you get if you learn data science. So another quick facts for them: 4 in 10 companies report their lack of appropriate analytical skills as a key challenge. So you see, 43% companies need people like you, or who want to be data scientists, who wants to acquire analytical capabilities. Okay, as I said, the median salary of a junior level data scientist is $91,000, but whoever manages a team of 10 or more data scientists, they earn base salaries of around, or more than actually, $250,000, and that's according to the report by the Bushworks. Okay, so also when data scientists change job, or when they switch jobs, they on an average they see 16% increase in their median base salary. So that's like a big number, because having said having worked in the industry, and I can tell you, I can give you for that. So also, as per International Data Corporation, it says that 181,000 people with deep analytical skills in the US it is required by 2018, and a requirement of 5 times that the number of positions with the data management and interpretation capabilities is required. So in the US alone, the market is huge. If you have the right skills, you can make big mullahs. Okay. So it's like so data science is a very promising career. As we talked about, here, what are the skills that we need, and what do we get if we have those skills. So the time for learning those skills, to gain mastery in that, it may take year. It will take year. There is no shortcut. But in order to gain, join entry level jobs, or in order to make quick quick entrance into data science industry, it's not that difficult. If you can gain those skills, and we will see in the next videos that how we learn, what are the tools that we learn for a data scientist. And if you learn those skills, you can definitely trust me, you can actually gain really good jobs across companies. It's not like be the startups, be the companies like data-driven companies like Facebook, Google, Microsoft, anywhere, Teradata or Amazon, housing, wherever you go. If you have those data science skills, you can get job very easily. And if you stay in that job and try to practice and learn more of it, gain more time on it, definitely you will have a very, very good career. Okay. So now let's talk about what this course is all about. Okay, so what are the topics that we'll cover in this course? So primarily we'll be dealing with, we'll talk about two platforms, two technologies that we'll use. We'll use R, we'll use Python. In the first part of the course, we'll talk about we'll use R. We'll talk about the fundamentals of R, how to do statistics using R. So primarily, and then we'll talk about the data manipulation, how to manipulate data and get it into the right format to present into visualization or do some predictive analytics on that. We'll learn that how to do it quickly in R. We'll learn that. Then we'll learn how to generate interactive charts, or high quality charts to prepare, to perform the exploratory data analysis, or in order to communicate your findings to the respective your corresponding actually person, or whoever you want to display it to or share it with. Okay. Then we'll talk about in the next part, or the later half of the course, we'll talk about the Python, fundamentals of Python, especially for data science, keeping that in mind. Then, excuse me. Then we'll talk about how to perform statistical analysis with Python. We'll talk about that. Then we'll talk about how to manipulate data in Python, and also we'll check the libraries in Python to perform visualization. And then at the end, we'll do the machine learning with Python. How to perform machine learning, build machine learning models with Python. Okay. At the last, we have thought of getting a guest lecture on Tableau, and the trainer is we'll find a trainer which will be like really industry expert, and we'll let you know as the time comes. This will be this is a hidden secret, and this session guest lecture will be a long one, maybe like 4 to 5 hours session. In this, you'll learn how to use Tableau or visualization software, wherein you can find you can make interactive dashboard to share your insights, and share it with public, whoever wants to whoever is actually interested. Okay, then we'll depending upon the how the interest about how the course follows, maybe we'll talk about, maybe we'll talk about next courses in the last section, maybe and that may be linear algebra or probability as in detail, and machine learning in detail. We'll talk about that, but that then there are some constraints on that, and we'll see how things goes for that in this course as of now. So now, if you have any questions for me, please feel free to drop in, and I'll just I'll try to I'll try to see questions here. If you have, just give to me. I'll this channel you can share. If you have any questions, feel free. Um, Anyone, feel free to reach out. Okay. So as I can see, there are not many people on the Q&A platform or as of now, and more. And it's pretty actually. Today is Diwali, so go ahead. Anyways, you people can go ahead and actually come again later. You can post your questions in the comment section. I'll try to respond to each one of you as soon as possible. So if that's all right, then thank you very much, and that's all we have for today. And we'll love to have you on the next class, wherein we'll start with the fundamentals of R. So that's it. So again, thank you very much, and wish you all a very happy Diwali, and have fun. Okay, let me just see the link, and I'll see what is the difference between machine learning and deep learning. Okay, so let me talk about Abhilash's question. What he said. So Abhilash, machine learning and deep learning. Okay, so there are a lot of questions coming up now. So just give me a moment. I'll take your questions one after another. So let's just begin with the first question that we have on hand: deep learning and machine learning. The difference between them. So machine learning, if you talk about, it will be like it is a bigger, let's take a superset. Okay, so machine learning is a superset, and inside that comes different types of algorithms. So one particular type of algorithm is neural net, that we call our neural networks or artificial neural networks. And that itself has grown into a complete stream of machine learning algorithms over the last few years, especially under the guidance of scientists like Geoffrey Hinton and Joshua Bengio. This has grown really great. But what's deep learning? Deep learning is actually a convolutional neural network. It is a type of neural network, and so machine learning. Deep learning is a machine learning, but all machine learning algorithms are not deep learning. So that's how I would like to put it. Okay, so deep learning it in itself has a different algorithms for different, especially with the if you talk about the speech and image data. Deep learning has come in really handy, and it has evolved, especially if you talk about the Baidu, the Chinese search engine. The speech translation thing that they were doing, the accuracy of 97% that they have gained, it's primarily because of the deep learning. And you can imagine that how tough it is of a language for how tough Mandarin is as a language. Like more than 49,500 characters they have in that language, and in order to in not just text but even speech, in speech, how to do it real-time translation is like really big thing. So deep learning is something neural net, and it is a type of machine learning. In machine learning, we have different algorithms like support vector machines. We have back decision trees, random forests, extreme gradient boostings. Then we have like different unsupervised clustering. If machine learning, if you go into that, then we will have like clustering algorithms like k-means clustering or hierarchical clustering or TSNE, these kind of algorithms. So that's how it is. That's how if you are convinced, let me know. Or if you're not, then please feel free to write your question again. Okay, Harish, I think the next class we'll have the next class in we'll notify you. Maybe we'll have this. We'll always have this over the weekend, but we'll see in the next. We'll definitely will have the class for next session. Next week on Saturday and Sunday we'll have 2 sessions, and right now we just had like 1 hour session because it was an introductory lecture. So in the next section, next session, it will be of like 2 to 3 hours sessions. 3 hour session, we'll have like a 1.5 hours session, and then 1 hour break, and then 1.5 or half an hour break, and then 1.5 hour and the next session. So we'll start with fundamentals of R. And so yes, again, the next class is on is scheduled next week. I'll update the event over the weekend actually. Okay. So any more questions? If you have, please feel free to write down. Please feel free to post your questions. I'll try to respond. As of now, chalo, thank you very much, and let me just go and stop screening and stop broadcast. Thank you very much. Happy Diwali.